Okay. So today we're very glad having this chance to interview Professor Huang from Donghua University. So it's very good to see you again, Dr. Huang. Would you like to briefly introduce your research group and research in general?
Yeah, I'm Zhongjie Huang, a professor from College of Material Science and Engineering of Donghua University in Shanghai. And our group is interested in surface and interfacial molecular science and device technology, including 3D nanopatterning, multiplexed sensing, and also surface and interfacial chemistry. Thank you.
That's very cool. As you mentioned yesterday in your presentation, so your research is mostly about the 3D nanoprinting, right? So how do you compare the 3D nanoprinting to the traditional 3D printing?
Okay, so the 3D printing technology that we are developing is indeed groundbreaking and very interesting. It allows the construction of multifunctional materials at high resolution freely. But it also allows the application of the light for the localized photolithography. So it's actually a combination of both bottom-up and top-down approach. It is completely different from the traditional 3D printing or the photolithography. As you know, the traditional photolithography has achieved tremendous success in the semiconducting industry in the past few decades. However, it is found incompatible with most of the functional materials that we are researching on. For example, organic molecules, hydrogels, polymers, nanoparticles, biological tissues. So there needs a universal platform to construct and position these materials. And for the resolution part, the traditional 3D printing technique, including inkjet printing, for example, their resolution is lower than 10 micrometer. So there is a gap between 10 nanometer to 10 micrometer. We need a printing technique to construct these materials. So we hope that the 3D nano printing technology that we are developing can help power the research of materials and multifunctional materials and device technology. And also it can be combined with AI, for example, machine learning, to help discover the next generation materials.
That sounds very, very promising. So it sounds like this technology is more compatible and it could be applied to more different types of materials.
Yeah, for material
right?
scientists.
Yeah, that sounds really cool. Do you think there is like a challenge in this 3D nano printing?
Yes, of course, device is a challenge because you need to, when you want to print at high resolutions, then you definitely need a device at the high resolutions. And also we need to expand the material range. So we are thinking for example, to make the technology more compatible or more universal for all of the materials.
I see. Cool. So, Dr. Huang, would you like to share your stories with Xilinx? And do you have any expectations to domestic instruments in general?
Yes, actually, prior to coming back to China, I actually had 10 years of experience studying and working in USA. I got my PhD from Department of Chemistry at the Ohio State University. And after that, I worked at the University of Maryland as a postdoc research fellow. And actually, when I became the professor at Donghua University, I started working with Xilinx. And actually, our collaboration is beyond my expectation. We are collaborating in a few projects, including hyperspectral imaging and the nano precision piezo stage. And we have witnessed the exciting and significant development of the company. And from our experience, the company can provide the devices and instruments with the state-of-the-art technology, but also cost-effective competitive options. So we firmly believe that the company's products will be not only popular in China, but also highly competitive around the world.
We're very happy to hear that we have cooperated for that long years. And we're really honored that Xilinx could be a part to be of help in your research. Okay. And many other professors, of course.
Yeah, we hope basically during this cooperation and the collaboration, basically we learn from each other, we listen to each other's needs, and I think I also learned from Xilinx.
That's really cool. Do you have any like expectations for domestic instruments in general?
Yeah, I do have high expectations for the domestic instruments. And I said, with the fast development in a lot of areas in China, for example, material science and engineering, and a lot of device technology in chemistry, in physics. So I think nowadays, the instruments in China, similar to the products labeled as made in China, not only presents the cost-effective options, but also with high technology. So I think they will be highly competitive, not only domestically, but also around the world.
Thank you. Thank you very much. So Dr. Huang, we really appreciate that you could take this interview, and thank you. Thank you very much. Thanks.